my third session on network analysis. Today we are going to discuss about the analysis of RLC series circuit. Myself, Dr. Sayanti Chatterjee, the Associate Professor of Electrical and Electronics Engineering Department in IARE. So first we will discuss about the what is the main objective. Already we have discussed the objective many times. Just one quick review. Understand the three-phase systems for star and delta systems, for star and delta connected systems, and perform the power calculation for balanced and unbalanced load. And what is the today's main objective? Present the necessary mathematical background of transient analysis of DC and AC circuits and study the transients using differential equations and Laplace approach for the series and parallel circuits. So this is my today's course objective of my today's lecture. Next, what are the outcomes? What the students will try to learn? Students will try to discuss the steady state response and response of electrical circuit for the AC supply. So today I am going to discuss the CO1, which is the discuss steady state response and resonance of the electrical AC supply. Others are CO2, which is the understand the concept of initial conditions of RLC elements to determine the transient response of first and second order electric circuits using differential equation approach and Laplace transform techniques. Here also we will just discuss about the RLC elements. CO3, the illustrate the locus diagram. CO4, solve the relation between line and phase quantities. CO5, demonstration of the operation of wattmeter to measure the three-phase active and reactive power, and last of all develop the various filters and their characteristic for the using the MATLAB. So now we will start our today's topic, that is the AC circuit analysis for an RLC circuits. So just before this starting, I will discuss the basics of the RL. We have already discussed in the last two sessions about the RL and C, and we have discussed about the pure R, pure L and pure C circuits. Just one quick recap. So there are, as we know, there are basically two types of electric elements. One is active, one is passive. So in the circuit elements, the R, L and C are basically the passive elements. In the resistance, the energy is dissipated, and L and C, the energy or the energy is stored. Now in an R and L and C, R we draw by this, L we draw by this, and C is we draw by this. Then we have discussed about the pure resistive circuit. So what will happen in a pure resistive circuit? Say we are giving one AC supply and this is a pure resistive circuit. Now we are giving I connected it. So current will flow, and what will happen? Always there is no phase difference between voltage and current in case of the pure resistive circuit. What does it mean? If this is the voltage we are giving, equation is Vm sin omega t, then we can tell that the current will follow the same path with the current, and it will be the Im sin omega t, and Im is equal to Vm by R. So this is a simple circuit, and if we want to draw it, if we want to draw the phasor diagram, what is phasor diagram? That also I have discussed earlier. What is phasor diagram? Phasor diagram is nothing but the linear application or pictorial application of the R circuit. With a simple R circuit, we can draw the, we can take this diagram. So if we think this is the voltage I am drawing with current I, then current and voltage, there is no phase difference. No phase difference means they have started from the same point and ended at same point, and pi by 2 both are having the peak. Not necessary that this is the thing, their starting point, ending point, peak point, everything is matching, then we will tell there is phase difference is 0. So if it is current, then what will be the voltage? The voltage will be in the same direction. In the same direction. So this is called the in phase. So voltage V is equal to I into R, and we are always in the same phase. Now, if we are going for the pure inductive circuit, what will happen? So again, I am drawing one pure inductive circuit, and as I told in the last class, we will always follow the civil rule. What is civil rule? In capacitor, I is leading and voltage is lagging. CIV. CIV means in capacitor, the current is leading and voltage is lagging, and VIL, voltage is leading, current is lagging. So what will happen? Current is lagging. So first we are drawing the voltage. And what is voltage? Vm sin omega t. Then what is about the current? The current we are drawing by green, and it will start maybe here by an angle phi, it is starting. So what is happening? It is lagging the voltage by an angle phi. By an angle phi means when it is 0, when the voltage is 0, current is in the negative peak or it is not 0. There is a phase difference by phi. So what will be the current equation? I am sin omega t minus phi. But now if it is a pure inductance, what will happen? In the case of the pure inductance, phi is always equals to 90 degree 0. If it is 180 and we are thinking it is 90, so phi is always 90 degree. So the equation will be I m omega t minus pi by 2. So again, if we draw this, if this is the current, then voltage is leading. Voltage is leading by current. So what will be the voltage? This is our voltage is Vm. If this is our I, this will be V. Or if it is our V, then what is I? I is always in the lagging. So you can see lagging means we are going 90 degree in the clockwise direction. So this is called the lagging. What will happen if we are going for the same direction for the capacitance? As we know, CIV. So capacitor current is leading and voltage is lagging. So what will happen in this case? I will show here again. So what will happen in this case? Again, this is Vm sin omega t. So what? This is Vm sin omega t. What will happen to current? The current will be 90 degree leading. So say here the current will start, and here the current will get the peak. So this is the current. Current will start before only. Current will start before only. So current is, so what is the current equation? I am sin omega t plus pi by 2 or plus 90 degree. And if we are again going for the phasor diagram, if this is V, so current is always leading. In the case of leading means in anti-clockwise degree, it is anti-clockwise, it is 90 degree. So already we have discussed these things in my last lecture. It is a quick revision. Now we will discuss about the AC through RL circuit, because in the practical case, pure resistor, pure inductance or pure capacitance is not available. So we are going for the AC through the RL circuit. So you can see this is the R and L. So what is the voltage? As this is a series circuit, the same current is flowing. So what is ER? ER is equal to IR. What is EL? EL is equal to I into XL. And we have to know, as this is a lagging current, then current will be in the 90, it will lag, the current is always lagging. Now you can see, so this is the voltage drop here. The voltage drop here is ER. What is the voltage drop here? Voltage drop here EL. And what is EL? As we wrote, I into XL, I into XL. What is ER? ER is equal to I into R, I into R. Okay, so this is the, and what is the ET? ET means total voltage, sorry. Yes, ET means total voltage is equal to ER plus EL. Remember, it is always the phasor sum or vector sum. We cannot add the magnitude only. So if you see, the first we will take, as this is a series circuit, current is fixed, so we will take I as the base. So this is the I. So what is ER? ER, we know that resistance voltage across the resistance is always in the same phase with current. So it is the ER. What is EL? According to the again civil rule, the voltage across the inductor is leading. Voltage is leading. VIL. So voltage is leading, I is lagging. So EL is leading by 90 degree. So ER voltage drop, what is? This is a vector sum or phasor sum. So we are taking ET in this line. So this is the total voltage. This is the total voltage. This is called the AC through the RL circuit. Now similarly, we are going for the AC through the RC circuit. So again we are giving the voltage and same current I is flowing here. So this is R, this is C. So what is the voltage VR? VR is nothing but the IR. What is VR? VR is nothing but the IR. What is VC? VC is nothing but the I into XC. What is VC? VC is nothing but the I into XC. So what is the total voltage? Total voltage in this circuit, again we are using the KVL, Kirchhoff's voltage law, that V is equal to VR plus VC. VR is equal to VC. Now what is VR? VR is equal to I into R plus I into XC. Already we have discussed these things. Now again from the civil rule we know I into XC, voltage across the XC lag the current. Now if we again want to draw it, the current I, this is the current I. So as this is the series circuit, we will take the current as the base. So this is our I current. Next, what is VR? VR is equal to IR. So it is the resistive portion. So it will be always in phase with current. As you can see, V is equal to I into R. As this is in phase, so as this is a resistive voltage drop, it will be always in phase. So VR is equal to IR. What is VC? Voltage across the capacitance. And what is that? This is the I into XC. As I know, I into XC lag the 90 degree by I. So we can see this is the VR. This is our VR. So it is lagging in nature. It is lagging in nature. Now the VR plus VC. VR plus VC. So this is the vector sum. Always we will do the vector sum. And what is the value of tan phi then? What is the angle phi? Phase angle tan phi. Tan phi is equal to, we can write VC by VR. If we divide the up and down by I, VC by I and VR by I, so what is this? Or we can XC by R. So what is phi? Phi is equal to tan inverse XC by R. What is phi? Phi is equal to tan inverse XC by R. Same thing for the, if we go for the RL circuit, if we got the phi, what is phi? Phi means tan phi is equal to EL by ER. What is EL? EL is equal to I into XL. What is ER? I into R. I cancel out. So phi is equal to tan inverse XL by R. What is phi? Phi is equal to tan inverse XL by R. So this is the phase angle. But this phase angle is lagging in nature and this is the leading in nature with respect to the current. Now we are going for the practical example when RLC all are in the series. So this circuit shows the resistance, then inductance and capacitance are in the series and AC supply of RMS voltage V. We are giving the RMS voltage V here. So what is VR? VR is equal to IR. IR means this is the VR. VR is equal to I into R. So this is the voltage drop across this. What is VL? I into XL. Voltage drop across the inductor and this is voltage drop across the C. So this is I into XC. So what will happen next? What will happen next? So IR plus IXL plus IXC. So what is V? Again using the KVL, we are getting IR. Because current is same, this is a series circuit. IR plus IXL plus IXC is equal to our total voltage. So this is the basic. Now we have to draw. So what is VR? VR is equal to voltage drop across the R. VL is equal to voltage drop across the L, which is, as I know, according to this again, CVL. In the inductor, voltage is leading. So voltage is leading the current by pi by 2 and VC means voltage is lagging by pi by 2. So if we draw it, this is our 0. This is our A point, that is the voltage drop IR into R is equal to V. AB voltage drop. This is our AB. What is this? This is the voltage drop in the XL and this is the I into XC, voltage drop across the capacitor. So this is our B, this is C and this is OA. So OA is the voltage drop and this is our current I. So this is the current I. So as we know, the current in the voltage drop across the capacitor, voltage drop across the resistor VR, this is our VR. VR is always with the same phase with current. VR is always in the same phase in the current. VL, the VL is always 90 degree leading from the, because voltage is leading 90 degree leading for the from the current, and similarly VC is 90 degree lagging the current. So if I want to write the equation, the KCL, V is equal to VR plus VL plus VC, and you can see VL and VC both are only 180 degree apart. So they are in the direct opposition. What we call this? This is called the, they are in the direct opposition to each other. So first we are going for the first one, when VL is greater than VC. First condition, when VL is greater than VC, what will happen? So this is our VL, this is our VC. We are doing the vector sum. We are doing the vector sum. So VL is greater, VC is less. So VL minus VC is the VL minus VC is always in the positive direction. So what is the voltage? Again, VR is this. So we are taking the positive angle. VL minus VC is equal to IXL minus IXC. So what is the phi flux? What is the phase angle in the case? Phase angle is, we know tan phi is equal to VL minus VC by VR, perpendicular by base. So we can write I XL minus XC by I into R, as I is constant throughout the circuit. So what R cancel out and we are getting XL minus XC by R. This is tan phi. So what is phi? Phi is equal to tan inverse XL minus XC by R. This is our phase angle. Now we are going for the second case. What is the second case? So this is the case when VC is greater than VL. So what will happen? This is a, as these are the 180 degree opposite. Now VC minus VL is greater. So what will happen? This angle will change. So if this is our VL and this is our VC, so this is the VC minus VL, and this is our, as usual, what is this? This is the VR is equal to IR, I, not a suffix R, I into R, and this is our current I. So as VC minus, so this diagram will come in the negative. So the total is, this is a positive circuit, this is the positive circuit, and this is the negative circuit. This circuit is totally in the negative side. So if we have two cases. So for the both cases we can write. First I will discuss. Sorry. So in this case, what is happening? So what is the overall voltage across this? I am writing here Vx. So what is Vx? Vx is equal to Vc minus VL. Vc minus VL. And remember, it is always negative because this is in the lagging side. The angle we are taking in the clockwise direction. So what will happen here? What is tan phi? Tan phi is equal to again Vc minus VL by VR. So if we again take the I into XL, I into XC, so it is coming XC minus XL by R. Generally we take that this is the clockwise direction. So generally we are calculate always anti-clockwise. So we can take minus of XL minus XC by R. So phi is equal to tan inverse minus of XL minus XC by R. So these are the two phase angles. Now, if we are going for the total, so if from this triangle or both triangle, this is our V, this is our V. So we can write both. You can compare with both. For this angle, VL my VR square plus VL minus VC square. Here also, this is your I into R means VR. This is E, so V square. This is VC minus VL. So from the right angle triangle, we can write IR square plus IXL square So actual equation is V square is equal to VR square plus if I give the name Vx, if I give the name Vx, VR square into Vx square. So IR square is equal to XL minus XC square is equal to, if I take I square common, I square is equal to R square plus XL minus XC. So what is I square? V square by R square plus XL minus XC square. So I is equal to V by Z. What is I? I is equal to V by Z, and we also get the equation Z square from the triangle. We can write Z square is equal to R square plus XL square plus XL square minus XC square, and we are writing by X. And what is tan phi? Tan phi is equal to XL minus XC by R. So if XL is greater than XC, phi is positive. If XC is greater than XL, then phi is negative. So XL is greater than XC means this is an which circuit? This is a leading circuit, and this is one lagging circuit. So we have to remember this too. Now we are coming for one numerical problem. What is this? A pure resistance of 50 ohms is in series with 100 microfarads. The series combination is connected across 100 volt 50 hertz supply. Find the impedance. So in the last class, as per I remember, we have discussed one problem of the RL circuit. Today we are going to discuss about a RC circuit. So a pure resistance is connected in series with a pure capacitance, and we are taking it as a connected to an 100 volt 50 hertz supply. Always before starting any problem, always draw a diagram of your given question. It is always a very good practice. So who is checking your paper, they will find that it is a perfect answer, and you will also not you will get all the data here only. So this is 100 microfarad. So what is the first step? We have to calculate the Z. So for Z, what is Z? Z is equal to root of R square, as there is no XL. So R square plus XC square. R square plus XC square. So what is the value of R is given? So first we have to calculate XC. What is XC? XC is equal to 1 by omega C. What is the value of XC? XC is equal to 1 by omega C. So 1 by 2 pi FC. So F value is given here 50 hertz. So 50 into 2 means 100. 1 by pi into 100 into capacitance 100, and it is microfarad. Microfarad means 10 to the power minus 6. So if we put the value 10 to the power minus 6, 2 pi F into C, we will get the value 32 ohm. What is the resistance value is given? In the problem, the resistance value is given as 50 ohm. So what is Z? Z is equal to R square plus X square, and we are getting as 59.4 ohm. What is current? As this, though we know according to the Ohm's law, I is equal to V by R, but for the AC circuits, I is equal to V by Z. So Z we got here 59.4. Voltage is given in the problem 100 volt. So we are getting the value 1.64. Next is the voltage phase angle. So what is the phase angle? Phase angle, we know phase angle means we can do it in a two types. First is the tan inverse XC by R. So what is the value? Tan inverse XC value we got 32 by 50. This is one procedure. Another procedure we can do, as this is the R, this is our XC and this is our Z. Sorry, it is I have drawn wrong. This is our IR, then this is our VRs. This is our VR, then this is our VC, because according to the civil rule current voltage is always lagging. So what is our Z? This is our Z. So this is our Z. So what is Z actually? The Z is nothing but the VR by Z. So if this is the phi angle, what is phi angle? Phi angle is equal to cos inverse VR by V, means R cos inverse R by Z. What is the value of R? The R value is given here 50 and Z value we got 59. So 50 by 59.4. So it is coming as 32.32 degree. If we are calculating the VR, what is VR? 50 already we got. Current value already we calculated. So VR is equal to I into R and VC is equal to I into XC. Actually, they have little different way. You can calculate 50 into what is XC? XC value we got 32. So this is also, but at some phase angle should be there. Next, a resistance of 20 ohm and inductance of 0.2 Henry and capacitance of 100 microfarad are connected in series across 220 volt 50 hertz. Means determine the following. So again, what is this? It is an RLC circuit. R, L and C circuit. So all are connected in series. We have to calculate the impedance. So what is XL? R, I will draw it nicely. R, L and C. What is the value of R? 0.2 Henry. What is the value of C? 10 microfarad. And what is the value of R? R is 20. And we are giving one source voltage of 220 volt. I think it is 220 volt 50 hertz. So this is our equation. So first we will calculate the XL. What is XL? XL is equal to, what is XL? XL is equal to omega L 2 pi FL. F is equal to 50 hertz. So it is coming 100 into 314. Sorry. 100 into 3.14 into L 0.2. So the value is coming 63 ohm. 0.2 into 314. What is capacitance? Capacitance we know this is 100 microfarad. So 10. What is the formula? XC. XC is equal to 1 by omega C. So 10 to the power 6 by, already we have done this, 2 pi FC. Or you can write like this. So what is the value? The value is 1 into 2.314 into 50 into 10 to the power minus 6 into 100. 100 microfarad and it is coming 32 ohm. So which one is greater here? XL or XC? Here XL is greater than XC. So the total diagram is in the positive. So what is the value of XL minus XC? XL minus XC is equal to 31 ohm. So it is XL is greater, so it can be called, it is an inductive circuit. So what is Z? Z is equal to, what is Z? Z is equal to square root of R square plus XL minus XC square. So XL minus XC we got 31. R is given as 20 ohm. So we are getting the value Z is equal to 37 ohm. What is Z? Z is equal to 37 ohm. So what is the current? Current is I is equal to 220 by 37. So it is 6 ampere. So what is VR? VR is equal to I into R, 120 volt. What is VL? I into XL, 278 volt. VC is equal to 6 into 32 volt. So it is 192 volt. Now you may ask, why the values are different? It is more than 200 volt. Again, I will remember the addition is not the numerical addition. This is the phasor addition. So if I draw it, the VR value is 120 volt. VL is equal to 278 volt. VC is 192 volt. So first we have to, this is not a simple addition. This is an, what is this? This is an phasor addition. And what is the angle phi? The angle tan phi is equal to, what is the angle tan phi? Tan phi is equal to X by R. So X is 31 by 20. So if we calculate it, we can get our angle phi. So what is impedance and what is admittance? 1 by Z is known as the admittance and the unit is mho, and 1 by X is known as the, 1 by X is known as the G. So Y is the conductance is written by J, and B is equal to the susceptance of the circuit. What is susceptance? Susceptance means B is equal to 1 by X. What is G? 1 by R, and 1 by Z is equal to Y, which is known as the admittance. Admittance Y is equal to 1 by Z. G is equal to conductance is equal to 1 by R, and B is equal to susceptance is equal to 1 by X, and all the three units are written in mho. They are written in mho. Opposite of ohm. So this is the, already we have discussed, this is the impedance triangle for the series RL and RC circuit. We have already discussed these things. So what we have discussed, this is the resistance XL and this is the Z, and this is the resistance, this is the minus XC and this is the Z. So what is Y? If we are taking is 1 by J, Y is equal to, remember these things, Z is equal to R plus JXL. So if we are taking the inverse, we are getting admittance Y is equal to G minus JBL. Similarly, we are taking here Z is equal to R minus JXC. So Y is equal to G plus JBC. Now we are going for the next problem. If the voltage applied is 10 minus 8J volt and current flowing through the circuit is 3 minus 5J ampere, determine the complex power and circuit constant. So what is voltage? Voltage is, first is given 10 minus 8J. What is the voltage? Voltage is given as 10 minus 8J. So what is, we will always, so this is in the first class we have told about the different type of coordinates. So this is given in the rectangular coordinate. Step 1, we have to, what is our step 1? We have to convert into polar form. So how to convert the polar form? Root of, if it is a plus jb, we can write a square plus b square. So what is the value? 10 square plus minus 8 square, and it is coming 12.80. How to calculate the angle? Tan inverse b by a. So it is coming 67 degree. Similarly, what is the value of current? 3 minus 5j. So how to calculate? Root of 3 square plus 5 square. So 5.83 at an angle minus 58.92 degree. Determine the complex power. So no need of calculate the VI cos pi. You can simply calculate the voltage into current. So how to calculate the two? If A at an angle theta 1 into B at an angle theta 2, the result will be AB theta 1 plus theta 2. So A 12.80, B 5.83. If we multiply this and this theta 1 and theta 2 will be added, and this is the power. What is Z? Z is equal to, what is Z? We know V by I. So A theta 1 by B theta 2. So what is the value? That it is A by B theta 1 minus theta 2. So if we put the value, we can get 2.19, first minus 8.08. So how to calculate it in the rectangular? Because we have to take the circuit constant. What is the form? The form is A cos theta plus B j into B sin theta. If we put the value, we can get 2.16 minus j 3.07 ohm, where 2.16 is the resistance and 0.307 is the reactance or X. So this is the first numerical problem. Next, so last question for today. A 240 volt 50 hertz AC supply is applied to a coil of 0.08 Henry inductance and 4 ohm resistance connected in series with a capacitor of 8 microfarad. Calculate the following impedance. Already we have done same type of problem. So one RLC circuit. What is the RLC circuit? The R value is given 4 ohm. What is the inductance? Inductance value is given 0.08. And what is the capacitance value is given? 8 microfarad. What is the voltage? The voltage is given as 240 volt 50 hertz. So what is XL? XL is always given as 2 pi FL. So 100 into 3.14 into, what is the value? 0.08, and the value is coming 25.12 ohm. What is XC? XC is equal to 1 by 2 pi FC. 1 by 314 into 8 microfarad. 8 into 10 to the power minus 6, and this is coming 398 ohm. Now in this circuit, which one is bigger? The bigger is XC. So it is a lagging circuit, or we can tell this is a capacitive circuit. Now what is Z? Z is equal to square root of R square plus XL minus XC square. As we are taking square, so it doesn't depend on the plus or minus. So Z value is coming 373 ohm. What is I? I is equal to V by Z. 240 by 373. So it is coming 0.63 ampere. And now phase angle. What is the value of the phase angle? The phase angle tan phi is equal to X x by r. So what is the value of x? 398 by 25.2. And what is the value of r? R value is given 4. So it is not 90 degree, it is near about 90 degree. What is the power? Again, power is equal to, what is the power? V I cos phi. Here they have not mentioned the complex power. What is in the question? The question has called the power. So what is power? Power is coming as, what is power? Power is equal to Vi cos phi. How to get the cos phi? From the triangle we can write R by Z, or you got the phi, you can calculate. What is Q? Q is equal to 1 by R of root of L by C. Don't write that XL by XC. This is L by C. So 1 by R means 1 by 4. L value is 0.08 Henry. Not micro, not milli. This is normal Henry. Divided by 8 microfarad. 0.01, so it is 1 by 4 into 10 to the power 4. 10 to the power 4 means 10 square by 4. So the Q value, the Q is coming 25. So this is called the Q factor, and details of Q factor we will discuss in our next class. So this is the we have to discuss the basic of all the series circuit. Next class we will discuss about the resonance, and we will discuss about the Q factor and bandwidth. So these are the textbooks what I followed, and this is the some from where I can took the diagram. So thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.